Hello, this is the reveal code that you are going to try to replicate. So I'm actually going to have you do this in two programs. The first one will not be animated. It'll just be a still shot. Okay, so over on the right, you can see the parameters that I have. So let me just run this with those parameters. So let's see, if I go down here, I can run it from the command window I just have this code called DerivativeReveal. Okay, so you can see what I've done is I've xmin and xmac gives us a domain. So you need to kind of declare a domain over which you're going to do the derivative. Oh, the speed equals 10 shouldn't be in this code. Speed has nothing to do with this code, so I'm just going to get rid of it. But the function string is important. So we're putting a function in. In this case, the function is x times e to the negative x squared. So it's kind of based on the bell curve, but I have a product with x and e to the negative x squared. And you do e's in MATLAB with exponential. You're exponentiating negative x squared. So that just happens to be the particular function we're doing right now. This should be interchangeable so that it can be any function that you want it to be. We're reading it in as a string, though. Although the AI may do it differently. So you need to be able to give it any function in the parameters. Let's see. And then you need to be able to take a point on the domain where you're going to analyze the function. Okay. NT is simply telling how many points are being used in order to generate the curve. So right now we're using 1,000 points to generate this curve. So when I look at it, so the important things, you've got to have a domain. This is so like if a teacher were going to use this program that you're generating, it would have to have a domain. It would have to have a function that you're working with. Okay, that will be the top graph, and the point of interest. All right. Now you can see when I ran the code, a couple of things happened. On the function itself, a tangent line to the function is plotted. Okay. It's not infinitely long. I decided visually it's better if it has a finite length. So it's a line segment, so a tangent segment as opposed to a tangent line. There is, and then the derivative graph gets plotted up to the point of interest. So the teacher could they could run this a couple of times. They could say, well, what happens if we integrate up to, differentiate? Let me, Command Z. What if that were a -1 first? The teacher could run the code. Whoops, come down to the command window and run the code to -1. And the students could see the graph up to that point. They could see that the tangent line is sloping downward, and we're dealing with negative derivative values. All right. Then maybe the teacher would want to say, well, let's see what happens when we go up to 0. All right. And they would run the code again. And now it goes to 0. And then we can go to 1. All right. And run the code again. And that gets us back to where we are. So the teacher could slowly roll out where the point of interest is, and make it go from left to right at whatever speed the teacher wishes to do so. So they could kind of analyze slowly what's happening to the derivative function. Okay. Now, version 2 of this is going to be just slightly. Oh, and one more aspect. Notice there's this vertical line here. It looks kind of like it jumped from one graph down to the other. That's a very interesting feature because it keeps our eye visually aligned with where we have taken the derivative up to. Okay, and it lines it up with the tangent line. So I like that vertical line in there to kind of keep us thinking about what's going on, especially when we go to the animation. Okay, so the animation has a speed factor in it, okay? Because to animate a graph, you need to plot many, many times, all right? We don't want to plot at all 1,000 points, okay? Because if we do, it'll probably take too long, Okay, so the speed actually skips points in the plotting so that it doesn't take too long. So there is a speed factor here, and let's go ahead and run DerivativeReveal 2, version 2, and you can see it automatically does the whole thing left to right. Okay, now let me add one more feature here. Let's say that we were doing from 0 to 5, and we were going to do the function x dot squared. Let's just do negative x dot squared minus 3. Whoops, that should be in the string. Minus 3. Okay, so here's another function. So we're going to do it from 0 to 5. Actually, we could still go negative 5 to 5. And let's run this and see what happens. Okay, so what's important here is actually focus on the vertex. You'll see that the vertex is at negative 3. If you're not careful, since that's the highest value, the top of the graph will be at negative 3, but we will always want to include the x-axis. Okay, so when we're doing calculus, we want to compare our function to where the x-axis is. So there's a bit of code in here that if the maximum value is in fact negative, it will reset the maximum value to 0 to make it higher, to include the x-axis. And conversely, if we only had, let me flip this, let me do negative x squared plus 3. All right, and let's run it again. If you flip it, the minimum value would be 3. But you actually want to make sure your graph includes y equals 0, which is the x-axis. So you need to reset the minimum value to be 0 if it was going to be something bigger than 0. So you want your minimum value to not be bigger than 0, and likewise, you don't want your maximum value to be less than 0. So you've got to get a little bit of that into the code. All right, that should do it. Let me stop the video here and have fun coding that. Oh, actually, before I depart, an interesting thing, if you did want to go a step further on this code, notice we're doing the first derivative below the graph. You could make it so that the bottom graph could be the second derivative instead. Okay, so you could follow along, you could have this animated, but figure out the derivative of the derivative and plot that in place of f prime of x, and the user could choose whether to do the first or the second derivative. So that isn't coded in yet, but that's something that you could do if you wanted to stretch this just a little bit further. Don't try to do all 3 at once because the graphs will get too crowded. But when looking at f of x, it might be neat to be able to see its second derivative instead of the first derivative. So you could consider doing that if you want to make this even better.